Okay, this is 5.2. 16 was the first one that some students had trouble with. We're supposed to maximize this integral, find a so that it is. So this says find the area between this graph and the x-axis. Well, the area here is below the x-axis if we start at 0, and it's negative. So if we have to start at 0, we've got all this negative. We're supposed to make this as large as possible, so we'd have to go clear to here to get just back to 0 because of the positive area and negative area would cancel each other. And then we'd keep going, and that would start adding positive area, and it would get up to a maximum at 4, and then it would start taking off again. So a equal 4 would create a maximum for this one. Now, for the second one, between B and C, well, we would not want the negative part. We would want to start here and then just keep adding positive up to here, and that would get the most positive we could get. So B would equal 1 and C equal 4. I guess it's that kind of a B. There we go. 33. We're supposed to evaluate this, and we have some rules, and one of the rules is that we can split this difference up into two separate integrals. Second rule is we can take a constant out, so this could be the integral from 0 to 4 of t with a 6 in front, minus the integral with 3 out of 0 to 4 of dt. And at this point, the rule says the integral of this is just this squared over 2. The integral of t is t 1/2 t squared. So 4 squared over 2. So we have 6 times 4 squared over 2 minus 3, and if it's just 1, it goes to, we just get the 4 times 4. So 4 squared is 16, and half is 8, so we get 6 times 8, 48, minus 12. Now for x squared, it says if it goes from 0 to something, it's this to the third over 3. But this doesn't do that, so we have to write this as two separate integrals. We can go from 0 to a squared, if 0 was in between here. And for the other one, we'd go from a to 0, but we can turn it around to be minus the integral from 0 to a of x squared dx. And so this one would be, the rule for x squared is it turns to x to the third over 3 with a squared in there. So it'd be a squared to the third over 3 minus, and so it'd be the same rule, but now with just a in there, a to the third over 3, which is a to the sixth minus a to the third over 3. On this one, splitting it up again, x would be, goes to x squared over 2, so it'd be 3 squared over 2 minus, and this goes to x to the fourth over 4, and the x is 3, so it's 3 to the fourth over 4, so we get 9 minus squared 9 through third is 27, 81. Oh, and this is 9 over 2 and 81 over 4. So if we make common denominator 4, this would be 18 minus 81, negative 81 minus 18, 81 minus 7163 over 4. On 54, we have similar deal that we had here. We're going to split it into 2. We'll go from, instead of from -2 to 0, we'll go from 0 to -2. So we have to go opposite because I'm turning it around. And that would be 2x to the third minus 3x squared plus from 0 to 2 of 2x to the third minus 3x squared. So we have a minus, and then we have the 2 would come out, and then x to the third goes x to the fourth minus 2 to the fourth over 4. And then we have a minus 3. This goes to x to the third, so minus 2 to the third over 3. Plus, and then we got to put 2 in place of these 2. And everything else will look the same. So it'd be 2 to the fourth over 4 and times a 2 minus 3 2 to the third over 3. So this would be 16 divided by 4. 4 times 2 is 8. And this 3 would cancel this 3, and this would be minus 8 times a minus is plus 8. And here we would have 16 divided by 4 is 4 times 2 is 2. And here we would have the 3's canceling, and we'd have minus 8. So we got negative 16 minus 6, negative 22. If I didn't make any arithmetic errors or lose a sign. Okay, and I got off the page on that one too, so sorry about that. Okay. So this says the area from 2 to 9 of this minus the area from 4 to 9 would be what would be left to be the area from 2 to 4. If we have the area from 2 to 9, whatever this curve looks like, minus the area from 4 to 9, so we take that off of that, we'd have the area from 2 to 4. $63. It says, given this, find this. Well, if it says from 1 to b turns out to be this, then 1 to 5 would be 1 minus 5 to the negative 1, which should be 1 minus 1/5, 4/5. And for this one, we want it to go from 1 to something, so we turn it around, so it'd be the negative of the integral from 1 to half of f of x dx, and this is negative, and we put a half in here, and we get half to the negative 1 is 2. 1 minus 2, that's minus 1, times a minus is 1. F of x is x. That looks like a line like this. And the area, the absolute value of the area is 1/2 from A to B. So if A was here and B was here, and at 1, that would area be 1/2. If we put some on this side, it would be negative, and then we'd have to add more on this side to get positive 1/2. And it says if we do the absolute value of this function, which would be like this, and we want 3/2, well, that whatever's negative here would turn positive and add to it. So if this was negative 1/2 here, turning it to positive would be positive 1/2. That's a difference between negative 1/2 and 1/2 is a difference of 1, which is how much we have here. So that's what we want to do. We want to start at negative 1, where the area is negative 1/2, and then go over here where we get a plus 1/2, and then go far enough further so that we get a total of 1/2 more. So we want to go far enough so that the area over here is 1. So to have an area of 1, the area of this would have to be 2. And so each side would be the square root of 2, so that the area of the square is 2, and the area under it would be 1. So this would be square root of 2, and this would be minus 1. Minus 1 to the square root of 2. Then when we just took the absolute value of this area, find the area, minus 1/2 plus 1/2 plus 1/2 would be 1/2, and the absolute value of that's 1/2. And if we take the absolute value of the function, we'd have plus 1/2 plus 1/2 plus 1/2, which would be 3/2. 72. Well, 2x minus 4 goes through minus 4 with a slope of 2, so it hits at 2. And if we're supposed to find the area from 1 to 3, we'd be finding this area plus this area. But it says absolute value, so this would go down and then up, and so I'd have this area plus this area. So I really need to do this as the integral from 1 to 2 of negative 2x plus 4. That's this line. That's the absolute value of where this goes negative, and so it'd be like this, plus the integral from 2 to 3 of 2x minus 4 dx. And using the rule for x, it turns to x squared over 2. So we'd have so we'd put in the 2 and then subtract the 1. But we can also just see from here that this is 1 wide and 2 high. So that has an area of 1, and that has an area of 1, and so the total area is just 2. And I think they wanted you to do that mostly from the graph. Okay, the comparison theorem says if this curve is always above or below this curve, then the area will be always less than. So in this case, x to the 5th. Between 0 and 1, we're doing fractions like 1/2 to the 5th and 1/2 to the 4th, or other fractions between 0 and 1. If you take this to the 5th, we get 1/32. We get this is 1/16. This is always bigger than this. So the area under the curve is always bigger than the area under this one, because this curve is higher than that one. Outside of that, outside of 1, past 1, like 1 to 2, this curve is always higher than this curve. 2 squared, 2 to the 5th is more than 2 to the 4th. And so, because the comparison theorem says if the graph is higher than the other one, the area will be more than the other one. And so, that's my justification for those. And I just did it. I didn't write it out, but that's what you would have to do. And that's it.